everyone and happy Dasara for one and all, and welcome you. I welcome you for one more class of chemistry. And dear student, you all may know that there is a revised syllabus from the PU board. Regarding that, among 16 chapter, the 3 chapters are completely deleted, and rest chapter what are there in that some of the concepts they have removed, right? So we will see the revised syllabus, and again what the government will take the decisions. We will always follow that, and then we decide whether it is correct or not. Why? Because in Pew board app only they have what given that notification, and what are the chapters they have they are deleted. They have mentioned that also, right? So in that regard, what I thought is I wanted to start chemistry in everyday life, but unfortunately, chemistry in everyday life, polymers, and general principle and isolations of element, I mean metallurgy, these 3 chapters are completely removed. So that's why what I thought is already this chapter during your first year I only taught that is biomolecule in biology. So what I thought is better it is to start a biomolecule. Why? Because in biomolecule we have a very less number of reactions, and one you can very easily understand these concepts. Why? Because you already studied these biomolecules in first PU of your biology, right? So with respect to that, so I will just give you a very brief introduction about biomolecule in this during this class. So if you have any queries like sir, we don't want biomolecule, you start another one. Like if you have any queries, then please do suggest me. Why? Because you people are very important for me, and for me it is not difficult to take any chapter from the chemistry. I can take any chapters during the online classes, but it is very important for you that how much you are getting or whatever I deliver during the class you are getting or not, that is very important, right? So that's why today I will just that's why I will not go through the complete biomolecule. I will just remind you what is biomolecule, and I will give just the introduction, right? And optical active, like I will give just a hint, and don't think that this chapter again if you suggest me, then I will stop this biomolecule here itself, and we will start one more. Whatever which chapter you suggest me, that chapter we will go through, right? So don't think that this chapter only sir will continue, right? So if you say yes, okay sir, you start this only, then definitely I will continue, right? So let us have our next topic, that is biomolecules. So already you know what is bio. Bio means life, right? Or living things, one we can say. Living things or life, we can say that the living bodies. What are the reaction taking place after having a food, right? Every living body or every living, you take any animals or a human beings, whatever it may be, living thing require a food, right? Very important. Why? Because they must and should have an energy or potential energy to work, right? So that's why what we require is we require everything. I mean, from our diets, not only protein, not only vitamins. We require carbohydrates. We require saccharides. I mean sugars. We require everything in a proper way. If anything exceeds in our body, then definitely our body will show some or other reactions, right? So in such a way, so for example, biomolecules such as we discuss about the macro and micromolecules, right? So say for example, large micromolecules such as proteins are the biomolecules, right? I mean, nucleic acid, lipids, nucleic acid. This is very important part, right? You all know about the nucleic acid, lipids, right? Vitamins or vitamins, we can say, sorry, lipids, right? So as well as small molecules such as primary metabolites, right? I will not go in detail about the primary metabolites. You already studied under your biology, right? So macromolecules such as protein, nucleic acids, lipids, vitamins, right? So these all play a very important role, and where we will get these from, right? We will get these from our diets, right? And they play a very important role in our body, right? So protein, if there is a body without a protein, then that body will be just like a what we can say stationary body, right? That body will not work as it want, right? So in this regard, so biomolecules are very important part. I mean, so this under the biomolecules, if you go for chemistry only in your future, then definitely you will be having biochemistry, and biochemistry is such a branch where we study everything about our body, what are the reaction taking place, and after having a food, how it is going for the digestion. I mean, reaction from where the digestion starts, right? Everything we study, and about the cell cycles. Already, you might have come across with these cell cycles, how the digestion takes place, what are the role of different enzymes, like catalyst enzymes are nothing but biocatalyst, we can say. So these all we study under the class what um, biomolecules. So in our chemistry, for your syllabus, we have very little biomolecule about biomolecule. So we study in detail about the carbohydrates. So you know already carbohydrates are nothing but very important source of energy, right? And we have so carbohydrate as well as the classifications of carbohydrates and all. We know already monosaccharide, disaccharide, oligosaccharide, polysaccharides, right? You have studied these all things in the biomolecules. Coming to some important, I mean, a basic part to understand biomolecule. So let me introduce some basic part, right? I will not go in detail. Why? Because I wanted you to suggest me which chapter should I start. So that's why today I don't wanted to send you a video, but I don't want to waste your time also. So that's why if I give some idea, then it will be good for you. For to, if you after your suggestions and all, if you give me a suggestion, then definitely we will go to that particular chapter itself, right? So we are studying these biomolecule under the organic chemistry. So this organic chemistry plays a very important role. Organic part, right? So organic part is nothing but the simple thing is C, right? So organic is nothing but this is a biomolecule is nothing but organic. Organic we are studying organic means we must and should concentrate about the carbon, right? So here we come across the some definitions like optical activity, optically active compounds, chiral carbon atoms, like we come across during these organic chemistry as well as in case of the biomolecules for your NEET and all. So see here, optical activity, and these optical activity we just see in case of organic compounds only, right? So optically active compound we study first, and then we will come with the optically active compound, we can say, right? So what is this optically active compound, right? So if a compound has a capacity to rotate a plane polarized light, right? Say for example, consider this as an organic compound, right? And what I am doing is I am just passing through a plane polarized light. Plane polarized light is nothing but the light which passes in a single direction, right? So if I move this, pass this plane polarized light to through the organic compound. If this organic compound rotates, rotation is of two types. You already know. It can rotate anti-clockwise or it can rotate clockwise. If it having a capacity to rotate the plane polarized light, then definitely such compounds are called as optically active compounds. That's very important. And these type of optically active compound we just see in case of organic compound, not in inorganic or physical compounds. Why? Because we require carbon very importantly to show the optical activity, right? So optically active compound, what it will do is it will rotate either clockwise or else anti-clockwise direction. If it is having a capacity to rotate any direction, it may be a left hand side or it may be a right hand side, then those such compounds are called as optically active compounds. If after passing a plane polarized light through the organic compound, if it unable to rotate the plane polarized light, if it unable to rotate plane polarized light, then such compounds are called as optically inactive compounds. So now the question comes optically active, and already we come across with the optically inactive compounds. Say for example, what I said, optically active compound rotates the plane polarized light, and other case is optically inactive compound does not rotate the plane polarized light. Coming to optically active compounds, right? So there are two rotations as I said already, right? So I will write one example. Tartaric acid, we say this compound is tartaric acid. So now, so which compound will be optically active? That is very important. Next part. So which compound should we say that this is the optically active, right? So the compound, I mean carbon, which is having four other groups around it. Groups are atom or ions, whatever it may be. They must be different. All should not be H, right? So all should be different. Then such compounds are called as chiral carbon, right? Chiral carbon. And now see, chiral carbon is nothing but having different compound around it. If the same compound is present, then that is not called as a chiral carbon, and it is denoted by a star one, we can say. Asterisk we say, right? So now see, if see, based on if chiral carbons are always optically active compounds, understood? Optically active compounds. Then now question comes, which is clockwise and clockwise, which will rotate plane polarized light into clockwise, and which will rotate plane polarized light into anti-clockwise direction, right? This is the next case, right? I'm just going step by step, right? Try to understand this. And now see here, if OH is present right hand side, very important. So if I see like this, right, then OH is towards the right hand side. If the OH is present towards the right hand side, then this optically active compound rotates that passed plane polarized light into clockwise direction. Understood? So I repeat, chiral carbons are nothing but having different compounds around it. One point. The carbon which is having four different compounds around it, those are called as chiral carbon. right? And chiral carbons are always optically active. Understood? Optically active. So now optically active means these are the two parts which we need to understand. So first part is clockwise and other one is the anti-clockwise. One, we show that the chiral carbon can rotate the plane polarized light. But which chiral carbon rotates plane polarized light into clockwise and which chiral carbon rotates plane polarized light into anti-clockwise? So the chiral carbon having its OH group towards the right hand side, which can rotate a plane polarized light into the clockwise direction. Understood? And now coming to next part, if see the arrangement may differ, right? You all know about this because in chemistry one, we cannot say that this chiral is having this structure only, right? It may differ, right, by element. You already know about this. So if the OH is present in a chiral carbon, OH is present at the left hand side, then it rotates a plane polarized light into anti-clockwise direction. So this is all about, see dear students, this is all about just a hint about basics, and these are very important for your competitive examination. Please go through it and suggest me please which chapter we should start. Otherwise, if you say, sir, you continue this only, then definitely I will start biomolecule itself with your syllabus, right? Revised syllabus, right? Thank you.